This video is on the objective complete the steps of a one mean hypothesis test with population standard deviation known. Alright, so sigma's known, meaning our test statistic will be a z-score, or we'll be looking at standard normal distribution. But this is with the p-value approach. Alright, so there was, again, the critical value approach where you found critical values and set up rejection regions and determine whether or not your test statistic was in one of those rejection regions. The p-value approach is finding your test statistic and then finding the p-value for that test statistic, right, which will involve some sort of area under the curve, either an area to the right or the left, or double some area if you're a two-tailed test. And then comparing that area, comparing that p-value to the significance level, right, to alpha, and then making your decisions from there. Alright, so this is number one, right, the first video on a question related to this objective from your Newton Alta homework that I'm seeing. So it might be a little longer than usual because I'm going to take you through every single step and explain things as we go along here. Right? All the steps of a hypothesis test using this p-value approach. Alright, so here's the problem. Now again, if you want to see some more stuff, click on more instruction and look at their videos, see their notes, look at their examples. Hopefully they help you out. Alright, so the question. Crowdfunding is one way for startup businesses to receive funding. A startup business is interested in using crowdfunding and would like to test the claim that the average amount of money raised on a crowdfunding platform is different than $5,000. To test this claim at the 5% significance level, the startup business collects the following data on a sample of 35 crowdfunding ventures and records the amount of money raised. The following is the data from this study. Okay. So they pull a sample, right? The sample size, 35 crowdfunding ventures. And the average amount of money raised by these 35 crowdfunding ventures is $5,500. And then this is unusual, but this is again where this is one of the problems where we know the population standard deviation. Right up here in the name of the objective, population SD is known. It says from past data, it is known that the population standard deviation, right, sigma, is $1,500. And then they say let's run this test, and I'm gonna do it to completion on a separate piece of paper, and then just enter all my information when we come back here to the website. Get rid of the calculator for now. So first step in any hypothesis test is some claim is made about a population, right? Some population parameter. Now they talk about averages. This is about means, so I'm going to have mu here. Now mu in this particular problem represents the average amount of money raised on a crowdfunding platform. So this is representing the average amount raised by all, right, the entire population of crowdfunding platforms, right, by all crowdfunding platforms. Now this claim that's going to be tested, right, I said this business would like to test the claim that the average amount of money raised on a crowdfunding platform is different than $5,000. So the claim they're testing is this. All right, they want to test the claim that this average amount of money raised is different than, not equal to $5,000. Right, then once a claim is established, right, some statement about a population parameter, then your hypotheses are set up, right? You have the null hypothesis, H0, which is what's going to be assumed to be true, right? And this will involve equality. and then the alternative hypothesis, which does not involve equality, and that's typically the claim. That's what's being tested. The alternative hypothesis is, usually what's being tested. So you see, this does not involve equals. This is not equals. So that's going to be, represented by the alternative hypothesis. And I'll just put, I'll just stop writing the dollar sign, right? So the alternative hypothesis is that the mean, the mean amount raised is not $5,000. And then the opposite of that is, the null hypothesis, the mean amount raised is $5,000. And again, this equal, this null hypothesis, this is what we're going to be assuming is true. We assume this is true. Right? We assume this is true, and then later on we'll decide if we think that assumption is good or not. Right? Do we keep this assumption, or do we reject it based on our sample? Right? So we assume that the mean amount raised is $5,000, and then see what happens when we take a sample. Now, another thing also that we can tell from this is, remember how, based on how the claim or the alternative hypothesis looks, that tells you what kind of a test you're running. One-tailed or two-tailed, left-tailed, right-tailed, or two-tailed. Well, here I have the parameter is not equal to some value. So this is a two-tailed test, right? Because if you're not equal, that means you can be on either side, right? Greater than or less than. So so we're running a two-tailed test. And what kind of a test you're running determines, how the p-value is found, right? Okay. So then after a claim is mentioned, the hypotheses are set up. Then we identify what's the significance level for the test. That's that alpha. Right. Now, if it's not mentioned, you can just assume it's 5%. That's a pretty reasonable significance level for most hypothesis testing. But it is mentioned here, and they said at the 5% significance level. So 0.05, 5% is the value of this alpha. Right. Then a sample is taken. Let's look at that sample. Now, a sample's taken. And it said this business looked at 35 different crowdfunding ventures, right? So the sample size here is 35. And of those 35, right, the sample mean, the average amount those 35 raised, right, which I'll call X bar, was $5,500. All right, I don't know why I put the comma there, but Now, we are told what sigma is, right? Sigma, the population, now this is not about the sample anymore, right? This is about the population. We are told that the population standard deviation, sigma, is known. And it's known to be $1,500. Now, because sigma is known, by the central limit theorem for means, right, CLT, central limit theorem, the distribution of all the sample means for samples of size 35, right? Imagine we were able to look at all possible samples of size 35 and look at all their averages, right? The average amounts of money that all those groups raised. The distribution of those averages would be approximately normal, with a mean called, mu x bar, and a standard deviation called sigma x bar. Right? And the mean of these sample means, remember, should be equal to the mean of the population. Now, the mean of the population, we are assuming, is $5,000, right? That is assumed from the null hypothesis. And the standard deviation of these sample means for samples of size 35, recall, is the standard deviation of the population divided by the square root of the sample size. So that would be 1500 divided by the square root of 35, which I'll punch into a calculator and we'll get an estimation on that. So I'll pull up my calculator, and we got 1500 divided by the square root of 35. All right, so it's approximately $253 and almost 55 cents there, right? So the standard deviation for this distribution of means, and I'll put the dollar sign here as well, is about $253.55. Okay, and I'll draw a little picture. All right. A picture of this distribution of the sample means. So I got a number line here representing all possible values of the sample means here for samples of size 35. It's a normal distribution, or approximately normal, right? So I got a symmetrical bell-shaped curve above this density curve. Then underneath the peak, right, on the number line here is the mean value of these x bars, which we are assuming, right? We are assuming from the null hypothesis that it is $5,000. So put 5,000 there. And then again, our standard deviation, about $253.55. So underneath these inflection points, remember the inflection points should be one standard deviation above and below. So this value here, approximately $5,253.55. And then this value here, about 4,000. Let's see, minus 250 would be 750, minus 3 would be 747, so $746.45 about that. So, and then and remember this is a normal curve here, so between these two values, one standard deviation above, one standard deviation below, there's about 68% of the area under the curve. Now that's not important. Right? What we're looking at is our sample. Where does our sample fall in this distribution? Our sample mean was $5,500. So that's over here somewhere. Mark it with like a star. There's $5,500. Right? There's our x bar, our sample mean. And then the big question becomes, if we assume the population mean is 5,000, and our sample mean came up at 5,500, is that far enough away from 5,000 to where I'll think 5,000 is a bad assumption? Because if our sample comes up really far away from 5,000, then we're probably going to say 5,000 is a bad assumption and we'll reject it. But if 5,500 is reasonably close to 5,000, then we'll say 5,000 probably isn't a bad assumption and we won't reject it. All right, so to determine how far away our sample mean is from this 5,000 from the population mean, find z-scores. Right? How many standard deviations, and that's the test statistic. Right. So what we're going to do is we're going to normalize this distribution, change it. And change everything to z-scores. Right, change it to the standard normal. Right, so now the number line is z-scores. Again, it's got a symmetrical bell-shaped curve, but standard deviation's 1. The mean is 0. Right, and that's a mean of 0. And I want to know, how far away, how many standard deviations above the mean is ours. So remember, I call that z-test, and I'll calculate it over here. Z-test, and it's just what's the test statistics? What's the z-score of our sample mean? So I take my sample mean of 5,500, subtract what the assumed mean is, the assumed population mean, that was 5,000, sorry. And then divide this by the standard deviation for the x-bars. Standard deviation for this distribution, which was this 1500 divided by the square root of 35. All right. So I'll go to the calculator. And now 5,500 divided by 5,000 is just 500. So the numerator is 500 divided by, and then my previous answer was that standard deviation. And you see it's 1.97 or 1.972. All right, so this test statistic, so that means our sample mean, our 5,500, is 1.972 standard deviations above the mean. That's not that far away. Right? Usually if you're more than 2 standard deviations away, that's usually pretty far. But this is less than 2. So our sample mean, our $5,500, is less than 2 standard deviations away from 5,000. Now we'll decide if that's too far away or not by comparing our p-value to the significance level. All right. Now remember, this was a two-tailed test. Right? Remember back here, this was a two-tailed test. So to calculate the p-value, remember our test statistic is above the mean, and if that's the case, the p-value is, you take the area to the right. Now if the test statistic was left, you take area to the left. You take the area to the right. All right, so I'm going to find this area to the right of our test statistic, and then that gets doubled for p-value. All right, so the p-value for our test statistic, this 1.972 z-score, is, again, it's 2 times this area. Right? So I'll go to a calculator. Right? We got the calculator here already. And I'm going to find this area. Right? So remember how to find area under a normal curve. You go second, distributions, normal CDF, and I want to find the area to the right of a z-score of 1.972. So the lower value is 1.972. There is no upper value, so I just keep that large 99999 value there. And we're on the standard normal distributions, mean 0, standard deviation 1. And this area is approximately 0.0243. So then the p-value for our test statistic is double this, right? So I go times 2. It's a two-tailed test, times 2. So the p-value is approximately 0.0486. 0.0486. Okay? And now we're going to use this p-value to determine if our test statistic is, what we feel is, too far away from the middle. And if it's too far away from the middle, then we're going to reject the null hypothesis. We're going to reject that mean of 5,000. And if it's not too far away, then we're not going to reject the mean of 5,000. We're not going to reject the null hypothesis. All right, so remember how we do this. I've done this in other videos, but remember you compare the p-value to alpha. If the p-value is less than or equal to the significance level, you're going to reject the null hypothesis. You're going to say, oh, our test statistic, our sample mean is too far away. That assumption must be bad. All right. We're going to reject it. And if the p-value is greater than alpha, you're not going to reject it. You're going to fail to reject. Don't reject the null hypothesis. All right, so remember alpha here was 5%. Alpha was 0.05. So I'm going to take my p-value, which was 0.0486. Alpha was 0.05. Which inequality do these numbers satisfy? Well, this is not greater than 5%. It's actually less than or equal to. All right, well, it's less than. Right? And if you're less than or equal to. So we're talking so this first inequality is that so we're gonna reject the null hypothesis, right? Because of this, we're gonna say, oh, that our sample mean here is too far away from 5,000 for us to feel that 5,000 is a good assumption for the population mean. We're gonna reject the null hypothesis. So going back to the statements, there was the null hypothesis, there was the alternative hypothesis, which was the claim, right? That was the claim, the alternative hypothesis. Now we're saying that we are rejecting the null hypothesis. Get rid of that. I don't like it. I don't want it. That means we are accepting the other one. And that was the claim. So that means we are supporting the claim. Right? If we're rejecting the null here, that means we are supporting this claim. We have enough evidence at the 1% significant, 5%. At 1%, we wouldn't have rejected, right? This is bigger than 1%. If our significance level was 1%, then we'd be like, we're okay with that. We're okay with the null here. But if we decide, I want to be, I want a significance level of 5%, then we're not okay with having the mean be 5,000. Right? So yeah, it really depends on the significance level. All right. So because we rejected the null, means we're going to accept the alternative or support the claim, right? The alternative was the claim. All right. So taking all that, I'm going to go back and we'll fill all this stuff in. Now remember, the null hypothesis was, the mean was equal to 5,000. The alternative hypothesis was the mean was not equal to 5,000. Then they have this interactive, normal distribution that you move some dots around on. Remember, since the mean was not 5,000 as the alternative hypothesis, this was a two-tailed test. So I move this dot down here to where there's two tails. Now those two tails are like, the rejection regions. They do have the rejection regions and critical values up here, but they also notice have the p-value mentioned, and we're going to focus more on that. All right, now I got the two-tailed test. Then we said we're going to, what's our significance level? They said it was 5%, right? So I move this over to alpha equals 0.05, and you see how that changes the rejection regions. It moves the critical values to negative 1.96, positive 1.96. But again, I'm not focusing on the critical values here. We're going to focus on the p-value for our test statistic. All right, then the sample size. It said they took 35 of these crowdfunding ventures. Well, hey, it's already at 35. Fantastic. The sample mean, right, the average amount of money raised by these 35 ventures was $5,500. So I move X bar to 5,500. Mu, what was the, now these two are talking about the population, mu and sigma. What was mu? Now mu, remember, we assumed from the null hypothesis that mu was 5,000. So I move mu to 5, come on, too sensitive. I move mu to 5,000. There we go, there we go, there we go. Okay, good. All right. And then sigma, right? We were given sigma. We were told that the population standard deviation was $1,500. So move this to $1,500. Oop, too low, too low. There we go. And now, look at this. All right. It's hard to tell, but remember our test statistic came back as 1.97. Or I said it was 1.972 on my paper when I wrote it out, but they have 1.97. It's kind of hard to tell here, but you can see that 1.97, if you were doing the critical value method, 1.97 is greater than the critical value of 1.96. So this test statistic is in this rejection region. So I would reject the null hypothesis, but that's not what we're doing here. We're taking p-value. Now remember, my p-value earlier was 0.04 0.86 I said. Now they're saying it's 0.0488. It's pretty close. I used the calculator they're using this picture here. So what they did was they took the area to the right of 1.97 and doubled it. Got this area here. Now remember, you compare the p-value to the significance level. See, 0.0488, that's less than or equal to alpha. That's less than 0.05. And if the p-value is less than or equal to alpha, you're going to reject the null hypothesis. And I would have done that in the critical value method as well. All right, so they're asking us to find, well, so what does this picture say as the test statistic? 1.97. What does this picture say as the p-value? 0.0488. And just fill in what the picture is telling me. Great. And then I think they're going to have us make a conclusion now, right? Do we reject? Now again, the p-value is less than or equal to alpha. So we reject the null hypothesis. All right, now it says here, now interpret the p-value. Remember, the p-value is 0.0488, which is, 4.88%. Now remember when we're doing a two-tailed test, you're talking about being on both sides. You're not just looking at the one critical value. You got two, right? Not critical value. The probability of observing a value of z 1.97 or negative 1.97 or more extreme on the outsides, if the null hypothesis is true, that's the 4.8. Your two-tailed test should involve the plus or minus, right? Not just one value, but two. And the probability of observing that value or greater or more extreme, right? The positive value or greater or the negative value or less is what the p-value states, 4.88% here. So it's this one. And it's only because it's a two-tailed test. You got the plus or minus. If it was a right-tailed test or a left-tailed test, you just work with the positive or the negative on its own. And then they probably have one more here where you're stating the conclusion. Right. Now the following, so they gave us all this, right? This is something we already found. The test statistic we found was 1.97. The significance level was given as 5%. We found this p-value. We don't need to move the dots, I don't think. But I will just do, and then significance level is 5%. Okay. Test statistic was 1.97. Okay, so all the same as the picture earlier. And I guess you didn't really need to do that because you're just filling in the dots here. Remember, we would reject the null. Now I said it in my paper. It's been a while, but remember, if I'm rejecting this, that means I'm accepting or leaning toward or supporting the alternative. And the alternative was the claim that mean, right, the average amount raised by these crowdfunding platforms was not $5,000. We're supporting that at this 5% significance level, right? So I reject the null, and I would say we're supporting it. So there is strong evidence to conclude that the average amount of money raised on a crowdfunding site is different than $5,000. We are supporting this. We're concluding that that alternative hypothesis or the claim is probably correct. Right, so we rejected the null, supported the claim. This one's reject the null, but there's not enough evidence to support the claim. Well, no, that's not what's happening. All right, we rejected the null, supported the claim. Great. All right. Wow, and it looks like there's only the one question. So if you get one question on this objective correct, that objective is over. Amazing. All right. So hopefully this video helps you out. Now you got to pay attention. This one ended up being a two-tailed test. Just remember how the p-value is calculated with a left-tailed test. It's just area to the left of the test statistic. And for a right-tailed test, it's just the area to the right of the test statistic. Right? You're only working with one value and not two, like with the two-tailed test. And you're not doubling any areas like with this two-tailed test. Okay. Alright, so it looks like it's only going to be the one video here. I apologize. Hopefully this helps. Alright, hopefully this helps when you're working on this kind of a problem on your own. And thank you very much for watching.